Imagine that I'm a student advisor. I'm helping a student, Elisa, to make academic plans. EventAction allows me to find archive students similar to Elisa so that I can refer to their activities and achievements to provide better guidance. On the EventAction timeline, I see Elisa's academic activities and when they occurred in each semester. Each row is a type of event and each column is a semester. The size of the gray square is the number of events in that semester. I can see Elisa had internship every summer and had been a teaching assistant during the first 2 years. On the right side is an outcome prediction. Elisa's desired outcome is become an academic postdoc. I can see that students similar to Elisa have a 25% likelihood of getting academic postdoc, and the likelihood for all archive students is shown as a thin bar, which is 29%. This is not very promising. She needs a good plan. A black box algorithm can generate a recommended plan. It suggests a lot of research activities such as RA and papers, which increase the chance of success by 4%. Since the decision is very important, I want to open the black box and understand how the plan was generated. First, I want to see how the students were selected as similar. In the similarity criteria panel, I see that the system sees Elisa as a female international student, and in the PhD program. I can see all the other criteria that were used and the distribution of the values for the entire dataset. The green color shows Elisa's values. I can change which criteria are used. Let's ignore a few. Currently, the 17% most similar students are selected, and the values for each criteria are summarized here. I can see the details of each student ranked by the calculated similarity to Elisa. I can add more controls by going to the complex mode. Now I can adjust tolerance range, for example, age, and program. I can also give more weight to certain criteria. I can also create new criteria by specifying temporal patterns. For example, no paper, and picking advisor in the late semester. The new criteria is added here. Several advanced visualization can help me review the set of similar students. Here's Like Me Donuts. There are 4 criteria, so I see 4 rings. The first one is gender. I can see that in the similar students, most of them are females like Elisa, but some of them are males. They are shown in gray because the value is outside the tolerance range. The next ring represents program. Among the females, most are master students, shown in dark green because it is within range but not exactly like Elisa. The bright green are PhD students like Elisa. A few are even undergraduates. The males are all master or PhD students. In fact, all their other criteria are within range. This is probably why they're in the results, even though the gender is different. Of course, I want to know where are the best matches. The partial ring tells me that those records are within range. And here's one that is an exact match, but for those 4 selected criteria only. I can remove records that I think are not appropriate. For example, the art students. I can also change the order of the rings. I can hover on the legend to filter the donut until I'm okay with the set of similar students. Next, let's look at the ranking glyph. The glyph helps me review how the similar students are ranked. Each glyph represents a criterion. Each line is a record, ordered by similarity. For the program criterion, I can see that records on the top of the list exactly matched Elisa, but not the ones at the bottom. For the age criterion, I see some unmatched records at the top. On the right side is the history heat map. I can see that this group of similar students had a lot of core courses early on and advanced courses later, just like Elisa. That's good. Selecting a branch in the donuts highlights the corresponding records in the glyph and heat map. It also brings those records to the top of the list for review. Also, whenever I adjust the criteria, every interface component is updated. Finally, I can generate a new recommendation based on the revised set of similar students. Now, I use the activity patterns as a reference to propose a plan of action. By default, we see the activities of all students similar to Elisa. Instead, I want to see only the data of those who became academic postdocs. The darker the background color, the more students had their activities in that period. Clearly, they published a lot of papers all along the remaining years. They also took advanced courses after their 4th years of study. I can make a plan for Elisa by adding activities to the timeline. I can see how the likelihood estimation changed until I'm happy with the plan. Based on the new set of similar students and the new plan, Elisa's likelihood of becoming an academic postdoc goes up to 40%. Now, I'm ready to review and further revise the plan with Elisa. But first, let's hide the individual student profile so only aggregated data is visible to her. The startup screen of EventAction shows usage guidelines and identifies potential issues and biases in the data. For example, the number of records is too small or the events may have occurred a long time ago. EventAction is a research project. It demonstrates key principles that can be developed in many recommender systems to give users greater control over important life decisions.